friends, today we will continue our discussion on laser. Today I will be discussing about the interaction of radiation with matter. As we have seen, laser stands for, here L is light, S stands for amplification by, S stands for stimulated, E stands for emission of, and R stands for radiation. That means laser is nothing but light amplification by stimulated emission of radiation. So from here it is clear that there is some amplification is taking place, right? So how this amplification takes place? What is the physics behind this? Let us understand this. This amplification is possible because of interaction of radiation with matter. So when light falls on some matter, there is some interactions, and because of which we are getting the amplification. Now let us understand how this radiation interacts with matter. So this is a matter. Here when we are incidenting some light, these are the photons. When these photons interact with matter, the physics cannot be explained with classical mechanics. We have to understand this physics with help of quantum mechanics, and hence we are calling this as a quantum system. Further, this quantum mechanical system which interacts with photons can be an atom or an ion or molecule or any subatomic particles like electron. So when these photons are being incident on a matter, they may interact with atom, ion, molecule or subatomic particles like electron. For this laser operation, we will be considering that the material are made up of identical atoms, and we are also considering two-state model or two-level system. What is the meaning of this two-state model or two-level system is, generally when we are considering a matter, we are having different energy levels. Okay, so for understanding this operation of laser, we are considering a system where we are having only two energy levels. So that is why it is written two-state model or two-level system. That means we are considering a system that consists of a ground state and an excited state. Only two energy level. One is ground state and one is excited state. This we are considering to make the calculations or to make the understanding easier. Thus, as per these considerations, we are considering atoms which are available in two energy levels. One is ground state and another is an excited state. Now let us see what are the different types of interactions occurring when the radiation interacts with matter. So the quantum process during the interaction are of three types. First one is absorption, second one is spontaneous emission, and the third one is stimulated emission. First we will understand these three processes qualitatively, then we will do the quantitative analysis. Let us first understand what is absorption. For this, as I already told you, we are considering two energy states. One is at energy E1 and the second one is at energy E2. This is the ground state and this is the excited state. And hence E2 is greater than E1. In case of absorption, we are considering the atoms in the ground state. When this atom in the ground state receives some photon from the incident radiation, and the energy of that photon is equals to the energy difference between these two energy level, then this atom will move to the excited state E2. So when a photon of energy h nu is being incident on the matter, this atom will absorb this energy and it will move to the excited state, and this h nu should be equals to E2 minus E1. Okay, so if the difference between these two energy level is equals to the energy of the incident photon, then this atom will absorb that photon and it will move from the ground state to the excited state. This is what absorption. So here the optical transition takes place from lower energy level to higher energy level. As we have seen, the atom has moved from the lower energy state, that is E1, to the higher energy state E2. Further, the energy is absorbed during the process, and here this is the equation for absorption. A is the atom at ground state. Now it is absorbing a photon of energy h nu, which is equals to E2 minus E1, and after that the atom is getting excited and it is moving to the energy level E2. A star denotes the excited atom and A is the atom at the ground state. So this is the equation for absorption. So what happens when this atom reaches the level E2? Whether this atom will stay here forever? No. It will stay here for a particular time. So the maximum amount of time for which the atom can stay in the excited state, that is energy state 2, is known as the lifetime. So lifetime is the maximum time for which this atom will stay at the excited state. Let us see what happens after the time interval, which is equals to the lifetime, that is generally written as tau. So after that, one physical phenomenon happens, that is known as spontaneous emission. So these are the two energy states, and now after absorption we are having the atom in the excited state, that is energy level E2. So this atom will stay here for a time tau, which is nothing but the lifetime. Okay, so after this time interval, what will happen? This atom will jump back, or it will come back to the ground state, and while it is coming back to the ground state, it will radiate a photon of energy h nu. Here also this h nu is equals to E2 minus E1. So we have seen that when an atom is getting excited to the higher energy level, after its lifetime it will come automatically to the ground state by emitting a photon whose energy is equals to the difference in the energy of the two levels, right? So this process is known as spontaneous emission because it is occurring spontaneously after the lifetime elapsed, right? So the optical transition takes place from higher energy level to lower energy level. As we have seen, it is coming from E2 to E1. Further, here energy is emitted during the process. During absorption, the energy was being absorbed by the atom, and here in case of spontaneous emission, energy is being emitted by the atom. And the equation is written as A star is equals to A plus h nu. A star is the excited atom which was in the energy level E2. Now when it is coming back to energy state E1, now it is no more excited and it is radiating or emitting a photon of energy h nu. Now coming to the third one, that is stimulated emission. How this emission is different from the previous one, let us look into that. So these are the two energy states E1 and E2. So when the absorption takes place, the atom will move to energy state E2. In the previous case, we have seen that after the lifetime elapsed, the atom comes spontaneously or automatically to the ground state. But in this case, before the completion of the lifetime, if some incident photon is coming and it is hitting this atom which is at the excited state, then this atom may come down before its life period or lifetime elapses. So this is the incident photon, and if it hits this atom over here, this atom will come back to the ground state, that is energy state E1, and during this transition it will emit one photon, right? So this is the emitted photon and this is the incident photon. Now this emitted photon and this incident photon, they both will move together. So this is the emitted photon and this is the incident photon. So initially we have incident one photon, and after emission we are getting two photon. Okay, so the optical transition takes place from higher energy level to lower energy level in this case also, and the energy is emitted during the process. But there is a difference between spontaneous emission and stimulated emission. In the previous case, no incident photon was triggering the emission, but here an external photon is triggering or initiating the emission, right? So the transition is initiated by incoming radiation. Now the emitted light is in phase with the incident light. You can see over here, this is the emitted one and this is the incident one. Both are in phase. The equation for stimulated emission can be written as A star is the excited atom and this is the incident photon whose energy is h nu and it is equals to E2 minus E1. After this photon triggers the excited atom, what will happen? The atom will come down to the ground state. So this is the ground state atom A, and we are getting two photons. One is the emitted photon, one is the incident photon. So here it is 2h nu. So this is the equation for stimulated emission. In case of spontaneous emission, we are getting only one photon. Here we are getting two photon, right? So this is the equation. Here you can see we are incidenting one photon and we are getting two photons as output, right? So in this case, multiplication of photons occurs. Let us understand this in more detail. So this is an excited atom. A photon is being incident on this. When this photon is triggering this excited atom, then we are getting two photons. This excited atom is coming back to the ground state and we are getting two photons. One is the incident photon, one is the emitted photon, right? Now these two photons, they will trigger two more excited atoms. So they are triggering two more excited atoms. And from this we are getting two photon, and from here we will be getting two more photon. Now we are getting four photons. These four photons, they will trigger four excited atoms. And here again we will be getting two photon. From the second one, two photon. Third one also will give us two photon, and from fourth one we will also get two photons. So all together we are getting 8 photons now. Okay, so these 8 photons, they will again trigger 8 excited atoms and we will be getting 16 photons. The process will continue. Okay, so initially we had one incident photon, that is 2 to the power 0. Then after the first emission we are getting two photons. Okay, so it is 2, that is 2 to the power 1 photons. Now these two photons, when they are triggering the emission, we are getting 4 photons, that is 2 to the power 2 photons. Further we are getting 8 or 2 to the power 3 photons, and this process will continue and we are getting the photons multiplied, right? Earlier it was 2 to the power 0, then 2 to the power 1, 2 to the power 2, 2 to the power 3. Similarly, if we will continue for n process, we will be getting 2 to the power n photons after n such process. Okay. So these photons are getting multiplied, because of which we are getting amplification in case of laser, and hence the process behind the operation of laser is stimulated emission. Now let us look into some of the characteristics of this stimulated emission. Here in case of stimulated emission, the stimulated photon and emitted photon both propagates in the same direction. The photon which initiates the emission and the emitted photon both propagates in the same direction. All the radiations generated have same frequency, phase and plane of polarization. And because of this, the waves are coherent and interfere constructively. The net intensity of light is proportional to the square of the number of atoms radiating light. And the stimulated emission is the key to laser operation. As we have seen, because of this stimulated emission, the photons are getting multiplied, and hence we are getting the amplification, which is the basic of laser operation. To summarize, the interaction of radiation with matter is of three types. First one is absorption. This is the type of transition in which atom in the ground state moves to an excited state through absorption of radiation, that is photons. Second one is spontaneous emission, where photons are emitted because of transition of atoms from the excited state to the ground state, and the transition occurs naturally without any external stimulation, right? The third one is stimulated emission. Here also the photons are emitted because of transition of atoms from the excited state to the ground state, but in this case the transition from the excited state to the ground state is triggered by some external radiation or stimulation. So these are the three quantum processes which generates because of interaction of radiation with matter. Today we have seen the qualitative analysis of these three processes. In the next class we will go into the quantitative aspects of these three interactions. Thank you all. If you like the content of the video, please press the like button and share the link with your friends. Also, do not forget to subscribe the channel. Thank you all.